What is apply maximum and minimum problems? Apply maximum and minimum problems is the process to find maximum or minimum value that called as optimization. We use apply maximum and minimum problems to do things like maximize the profit in a company or minimize the cost or to find the least amount of material to make a particular object.
The Carnation Company of LA produces and distributes Friskies buffet cat foods. All flavors come in cylindrical containers. A 6-ounce can of Frisky buffet mixed grill has a volume of roughly 14.5 cubic inches and has the following dimensions, which is the height is 1.75 inches and the radius is equal to 1.62 inches. The questions that we want to solve for this problem is the first one is to prove that the surface area of canned food is equal to 2 pi r square plus 29 over r. The second one is to find the values of r and h that minimize the total surface area of the can and give the answer correct to 2 decimal points. And the last but not least, to find the minimum surface area of the can.
Now, I will start with the first question. From the question, we need to state the surface area of the can is 2 pi r squared plus 29 divided with r. We can use two formula, which is first, the formula of surface area of the cylinder AC equal to 2 pi r squared plus 2 pi r h. The second one is the formula of the volume of cylinder VC equal to 2 pi r squared h. From the question, it states the value of the volume is 14.5. We can substitute the value into the formula of the value. And then to make the h as the subject, we need to divide the 14.5 divided with pi r squared. Now, we can substitute the h into the surface area of the cylinder. From here, we can eliminate the pi r and pi r squared. And then we will get we will multiply the 2 with 14.5. And now we have proven that the area of the surface is equal to 2 pi r squared plus 29 over r.
Now move on for the equation to find the value of r and h. For the first step, we have to find their value. So a equal to 2 pi r power of 2 plus 29 r power of negative 1. So differentiate dA over dr equal to 4 pi r minus 29 r power of negative 2. And we got 4 pi r minus 29 over r power of 2. Next, for the second step, we have to write the derivative equal to 0. So, dA over dr equal to 0, which is 4 pi r minus 29 over r power of 2 equal to 0. From this, we can get the r. So 4 pi r equal to 29 over r power of 2. 4 pi r power of 3 equal to 29. Then r power of 3, 9 over 4. inch. Next, for the third step, we have to use second derivative test. So, d power of 2a r power of 2 equal to 4 pi plus 58 r power of 3. So we get 4 pi plus 58 over r power of 2. Now we know that r is 1.32 inch. So we substitute in this equation. 4 pi plus 58 over 1.32 power of 3 equal to 37.78. So this value is more than 0. So R equal to 1.32 inch is the minimum value.
Moving on to the last question of this problem. The third question, we need to find the minimum surface area of the can. Given from the first question, we have already obtained the equation for the surface area of the can. Now, since we have already obtained the value of R, which is equals to 1.32 inches, we just substitute the value of R into the equation that we have already obtained from the first question. After we have substituted the value of R into the equation, we can calculate it normally and we can get the minimum surface area of the can. So, in conclusion, the minimum surface area of the can that we have already obtained is 32.92 inches square.
By applying differentiation method to the question, we can find out that this method can be used to calculate the given question. We have proven that the surface area satisfies the formula. We have find the R and H amount that minimize the total surface of the can, and we also have find the minimum surface area of the can. Hence, differentiation method can also be applicable to solve our daily problems.